Hello. In first statistics class, we discussed statistical description of data. The first unit. In that section, we discussed what is statistics, different definition of statistics, everything we discussed. Today, we are going to study more about that chapter. Now, we are going to study about variable. Have you ever heard about variable? Yes, everyone heard about variable. The variable, that word comes from the word vary. That means the value varies. For example, mark of students in a class. That vary. Someone has 48, someone 41, and that values varies. The name, the word variable comes from the word vary. Variable is a measurable data. Variable is a measurable data. It's also known as quantitative characteristics. Quantitative characteristics. Okay, what is quantitative? Quantitative means that directly measured. A variable can directly measure. Mark of a student, a salary, that everything we can measure. So, these values are known as variable. The word variable comes from the word vary. There are different types variable. What are they? Discrete variables and a continuous variable. The variables are two types. Discrete variable and a continuous variable. Then, what is discrete variable? Discrete variable that can measure, that countable variable. Discrete variable assumes a finite or countably infinite number. We can count 1, 2, 3, etc. We can count the values. That is discrete variable. Example, number of petals in a flower. We can count 5 petals, 6 petals. Yeah. Number of road accidents in a localities. Everything we can count. 1, 2, 3, etc. That is discrete variable. Another type variable is continuous variable. That is uncountable. The value of discrete variable in a given interval. That assumes the values from a given interval. The values from 1 to 2. There are so many values, 1.1, 1.11, etc. So many values are there. That is uncountable. Continuous variable assumes values in a given interval. There are two types variable, that are discrete variable and a continuous variable. Today we discussed about variable. What is variable? Variable is quantitative characteristics. Quantitative, that is measurable data. The word variable comes from the word vary. There are two types of variable. What are they? Discrete variable and a continuous variable. Discrete variable assumes finite or countably infinite number of values. Continuous variable assumes any value from a given interval. Okay? You got it? Variable. Then, next we are going to discuss about frequency distribution. What is frequency distribution? What is frequency distribution? What is frequency? Frequency. The number of times a particular value repeats. That frequency. Okay. Frequency distribution. That is, we arrange it. That is a tabular representation. Tabular representation of statistical data. In that, we arrange the data in ascending or descending order according to individual value or a group of values, the characteristics understood. A tabular representation of statistical data arranged in ascending order. Ascending or descending, anything. Ascending order relating to a measurable characteristics according to individual value or a group of values of the characteristics understood. We can arrange the data in a tabular format. In one column is we can write variable, x values, variable, and another column we can write how many times these all values repeat, frequency. This is known as frequency distribution. Frequency distribution. It's a tabular representation of statistical data. Okay, frequency, how many times it repeats. Frequency distribution, that is a tabular representation of statistical data in ascending order relating to measurable characteristics according to individual value or group of value of the characteristics understood. Simply, we can form a frequency distribution using two columns. In first column, we write variable, height, 150 centimeter height, 144 centimeter height, etc. Can write. And how many students are in that category? That is in the frequency column. Clear? We can form a frequency table here. Look, one example is here. A review of the first 30 pages of statistics book reveal the following printing mistake. We can see so many numbers are here. In screen, we can see so many numbers. Look here, 0, 1, 3, 3. Likewise, you can see some numbers. How can we form a frequency distribution table? Look, which is smallest number? 0. Okay, which is largest number in that group? That is 6. That start from 0. So many numbers are here. 0, 1, 2, 3, 4, 5, 6, etc. That value changes, varies. This is known as variable. We can form a frequency table using this data. Look, I will show you the next page. Here you can see mistakes. You look at the first column only. We can see there mistakes. So many mistakes are there. We can see 0 mistakes, 1 mistake, 2 mistake, 3 mistake. Okay. So we write the mistakes, that is variable, that in the first column. Okay. How can we form a frequency table? We can use tally mark for that. Look, in first column we write 0, 1, 2, 3, 4, 5, 6 numbers. And first number, what is first number? That is 0. Okay. Look, in this tally mark column, first we write 1. Only one line there. Okay. Only one line. Because that indicates one time that 0 occur. In next number, what is that? 1. Okay. In that position, in 1. In the mistake column 1, we can write again 1. That one line. And look, next number 3. Okay. Then in the 3, that mistake 3. In that section, we want to write 1, 1. Likewise, we add that that lines, that tally marks. After 4, we draw a slanting line. Okay. In the 5th line, we draw like a slanting line. We finished all numbers such a way. Okay. Then count the numbers. Look, in this tally mark 0. How many times are there? That 5 times. That is the frequency. Okay. In 1, that again 5 times. Look, 2, 5 and 1 more there. That's 6 times. 3, that also 6. Again 4, 4 times. 5, 2 times. 6, 2 times. Look, that 30 days data are arranged in a frequency table. In a frequency table, there should be 2 columns, mistakes and frequency. to write that frequency value, we use the help of tally marks. Clear? Okay. And next question. Look here. In the next question, what it is? Following are weight in kilograms of 36 students. Construct a frequency distribution of weight taking class length as 5. This is data regarding the weights of 36 students. Okay, different weights are here. Okay, but we want to construct a frequency distribution table. Class length as 5. Class length. In each class, 5 elements are there. Class length means how many are there? The length of the class. Okay. How can we construct a frequency distribution table? In this also, we want to find the smallest number and the largest number. Look at the data. Which is the largest number? I think that is 73. Smallest that is 44. Okay. Largest value is 73 and smallest value is 44. Then range of that data. Range of that data that indicate the difference between largest and smallest. Maximum value and minimum value. Difference between maximum and minimum value. But it is maximum 73 and minimum 44. Then range of that table is 29. 29 values are there. Okay. We want to construct a table with a length 5. So, we want to first, how many classes? First identify how many classes are there. How many classes are there? To identify the number of classes, we want to divide the range by class length. We got range, that is 29, and class length is 5. Look here, 25 divided by 5. That's not exactly 6. I wrote here 6 but not exactly 6. That's approximate value only. 5 point something only. I take it as the next whole number because the number should be in integer. So, I got the value as a decimal. I convert that into next integer. Okay. So, we can write it as 6 class intervals. Okay. 6 class interval. Look here. I am going to write class. Okay. First class, that the minimum value is 44. Class length 5. Now, I am going to construct a class. Okay. 6 class I want to make. First of all, I wrote 44 and 5 length. 44, 45, 46, 47, 48. 44 to 48. Look here. 44 to 48. First class. Next class. Then I am going to take next number. 49, 53. 49, 50, 51, 52, 53. And 5 is the next class. Then next number. 54, 50, 54 to 58, 59 to 63, 64 to 68, 69 to 73. Look, how many classes are there? 1, 2, 3, 4, 5, 6, 6 classes are there. Then I want to arrange the frequency also. What we did in the previous question. That similar manner, we wrote tally mark and write frequency table. This is the method for creating frequency table. Understood? Okay. Next. Now we zone class length frequency table everything. Then we are going to study something about that class interval and class. Okay. We are going to study about some terms related with that. Now, what is class limit? class limit. We saw different classes 44 to 48, 48 to 49 to 53. Likewise, so many classes we discussed. And what is class limit? Class limit indicate minimum and maximum value of the class interval contained. Minimum and maximum value. That minimum value indicate the lower class limit. Maximum value that indicate upper class limit. You can see 44 to 48 is a class interval. Okay, 44 minimum value, 48 maximum value. Clear? Lower class limit 44, 48 upper class limit. Look, we see what is class limit. Then, what is class boundary? Okay, class boundary. So also a class limit. Actual class limit of a class interval. Actual class limit. Class boundary also class limit. Actual class limit of class interval is known as class boundary. In that time, I want to discuss something more about that. For this, I am going to discuss different classes. There are two types classes are there. You know, two type classes. Inclusive class and exclusive class. Look, first I am going to discuss overlapping class or exclusive class. Then only you understand clearly this portion. Okay, overlapping class or exclusive class. What is this? Look, overlapping class. In the screen we can see 10, 20, 20, 30, 30, 40. Look, the upper limit of first class is lower limit of the second class. Upper limit of second class is lower limit of the third class. Like we can see two numbers that 20 is repeated in first class also. In first class 20 is there, and in second class also that number. This type class is known as exclusive class. This 20 in 10 to 20 we exclude the value 20 and we include that 20 in the second class only. We take below 20 values only in that first group. The upper limit excluded in this group. Okay, here we can see the limit coincide with the class boundary. Now, here class limit and class boundary are equal. In this type class, that is exclusive class, in this type class, class limit and class boundary are coincide. Okay, what it is lower class limit? That only lower class boundary. Upper class limit, that upper class boundary. Overlapping class or exclusive class. In that type class limit and class boundary are equal. In the first class, that is 10, 20. Lower class limit 10, lower class boundary 10. Upper class limit 20, upper class boundary 20. It's in the case of overlapping or exclusive class. Okay. Next, we are going to discuss about non-overlapping class or inclusive class. Inclusive. In lower limit and upper limit. In inclusive class, lower limit and upper limit included in that class. Example, look here, 0, 9, 10, 19, 20, 29. In the first class, 0 and 9, both are in that first class. And 10 and 19, both are in the second class. Lower limit and upper limit included in that class. This type class is known as inclusive class. Here is a difference in the case of lower class boundary and upper class boundary. How can we find out lower class boundary? Look here, 10, 19. In that first class, lower class limit 10, upper class limit 19. Here, lower class boundary, we can calculate lower class limit minus d by 2. Look here, d by 2. I wrote the formula there, LCL minus d by 2. LCL, lower class limit. And then what it is D? D is difference between the lower class limit of second class and upper class limit of first class. Okay, the difference between lower class limit LCL, not DCL. Some mistake are there. Not DCL, LCL. Lower class limit of the next class and upper class limit of the given class. Lower class limit of the next class and upper class limit of the given class. Difference between lower class limit of the next class and upper class limit of the given class. Look here. Here we consider the class 10, 90. Lower class limit 10. Upper class limit 90. Then lower class boundary. In the first class, upper class limit 90 and the next class. In the next class, that is 20, 29. Then lower class limit 20. Difference between 20 and 90, that is 1. Okay, that is 1. And D by 2, that is 1 by 2, 0.5. Then lower class boundary is 10 minus 0.5, 9.5. Upper class boundary 19 plus 0.5, 19.5. Then the class, we can write it as 9.5, 19.5. Then next class, 20, 29. Look here, 20, 29. We want to subtract 0.5 from lower class limit, 20. That is 19.5. And add that 0.5 to upper class limit, 29.5. This is non-overlapping class or inclusive class. That we discussed lower class boundary, upper class boundary, lower class limit, upper class limit. The values, the minimum value and maximum value included in that class, that is known as class limit. Actual class limit is class boundary. In the case of overlapping class or exclusive class, class limit and class boundary are equal. But in the case of non-overlapping class or inclusive class, there is slight difference. We have one formula. Lower class boundary is equal to LCL minus D by 2 and UCB is equal to UCL plus D by 2. Clear? Then next point, midpoint of a class. We get one class 10, 20. That is a class interval, yeah. What is the middle value, midpoint of that class? Midpoint, middle value, and it also known as class mark. Look, class mark, midpoint, middle value. These all are same. How to find middle value or class mark for a class interval? Middle value, lower class limit plus upper class limit divided by 2, or lower class boundary plus upper class boundary divided by 2. To find out middle value or class mark of a given class, we want to take lower class limit and upper class limit. Add these two values and take the half of that value. That is midpoint or mid value or class mark. Clear? Then next portion, width or size or height of a class interval. Width or size of a class interval. How to find the size of a class interval? That is nothing. This is a difference between upper class boundary and lower class boundary. To find out the size of a class interval, we want to take the difference between UCB and LCB. Clear? Then next we are going to study about cumulative frequency. You know what it is, cumulative frequency? Yes, we are going to discuss about cumulative frequencies. There are two types of cumulative frequency. Less than cumulative frequency and a greater than cumulative frequency. Less than. Okay. Less than cumulative frequency means number of values less than the value or less than or equal to the class boundary. Number of values less than or equal to that class boundary. Then similarly, what it is greater than cumulative frequency? That the values greater than or equal to that class boundary. There are two types: cumulative frequency, less than cumulative frequency, and a greater than cumulative frequency. In less than cumulative values, cumulative frequency, that indicate the number of value less than the value or less than or equal to that class boundary. Similarly, we can say greater than cumulative frequency also. Okay. Then next term, frequency density of a class interval. Frequency density of a class interval. How can we find out frequency density? There are so many questions to find out the frequency density of a particular class. How can we find out? Okay, frequency density of a class interval. Frequency density of class interval is equal to, we want to take the particular class 10, 20. There are 5 frequency. 5 times that value repeats. Okay, then the frequency of that class is 5. Okay, class width 10, 20. Class width 10, 20. What is width of that class? 10. Okay, 10, 20. Difference between class width is equal to UCB minus LCB. 10, 20. Then 20 minus 10. That class width is 10. Okay, frequency of that class divided by class width. Then class density, frequency density of a class interval is the frequency of that class interval divided by class width. Okay, then next terms, relative frequency. Relative frequency. We want to find out a particular class relative frequency. We want to take the frequency of that class and divide that value by total frequency. Relative frequency of a class interval is equal to class frequency divided by total frequency. The next term, percentage frequency of class interval. Percentage frequency of class interval. To represent values in percentage, we want to multiply that value into 100. Then we know what it is relative frequency. Relative frequency is class frequency divided by total frequency. To find out percentage frequency, we should multiply that value into 100. That is class frequency by total frequency into 100. Clear? Today we discussed about what is variable, different types variable, and class. Different type class, inclusive and exclusive classes, and the terms related with the class area. Okay, we continue this chapter on next video also. Okay, thank you.